I can show you a nice weather map with pictures and show you whether there's a storm coming tomorrow and all of that stuff, right? If you are asking the same question while you're driving, what you really want to know is a quick short message that's spoken to you. The example I used just now was weather for Beijing. Let's say instead you are you are somewhere else and you say the weather in Athens. Most of the time you would expect the right answer to be the weather for Athens, the capital of Greece. Not so if you were in some part of America where there is a small city called Athens. I think there is an Athens in Michigan and there is an Athens in Texas. And for those people, when you say weather in Athens, you want that weather, right? So the relevance part is hugely important, the speed is important, and then the presentation is important. Now that's true for all users. How does this actually change in the context of somebody who's blind? It just gets more important. So to give you a very simple example, suppose you send me a package by UPS in the United States. The tracking code is this big long number. Now, I can go to the UPS site, I can work through their website, and it's a fairly busy, complicated website, and you can go type that thing in, and then you'll get this big, complicated page back, and then you can look in it. So as a blind user, to find out when that package will arrive would probably take me about 7 or 8 minutes. Instead, I type that same tracking code at the Google search box, and in 30 seconds it comes back and tells me when my package is arriving. How many minutes did I save? I saved 7.5 minutes on that one task. And in the information world, this is money, right? This is equality, and this is not just about, oh, it's nice to be able to do it for a blind person. It's about gaining the same level of efficiency as your peers. Flip to the next slide. So remember I said this is about giving access to all the world's information. But here is where Google today makes a huge impact in the space, because not only do we give access to all the world's information, by the work we do, we are actually changing the definition of all the world's information. So when we started, it was all the information on the web. But then a lot of the critical information, a lot of the world's critical knowledge was not in the web. The Books project is about bringing all the world's books online. Now, ask that question in terms of what it means to somebody who cannot see. Suddenly, every one of those books for which I would have needed a student volunteer to come and read it to me is there on the web, on the cloud, available to me from wherever I am in a form that I can use. This is enormous. YouTube, right? Bringing all the world's video online. Today we started running automatic speech recognition on YouTube videos, and we can automatically caption it. Now, what happens as that gets better and better, right? Basically, you could, as a student in one part of the world, listen to a college lecture from somewhere else, have it recognized for you, captioned for you, translated for you. It's amazing. Maps, right? Maps started off very simple by, well, you can put a map on the web and then you can look at it. Today we have driving directions, we have walking directions. Alan was talking earlier about the world is at your fingertips, and later I'll show you a demo where it's actually at your fingertips, because I can bring up maps on my phone and feel it. Not only can I feel the map for Mountain View, I can feel the map for Beijing, I can even feel the map for where I studied 25 years ago, and it's truly incredible what you can do. So flip to the next slide. So the way to think about all of this then is, the web is this platform that we talked about. The work we do at Google is, you can view as connecting people with all of that information. And in some sense, if you think of the web as this big information highway, think of this as then building on-ramps to that information highway that are accessible, right? So making that information available to users who cannot hear, users who cannot see, users whose eyes are busy, automatically leads us to developing technological innovations that significantly improve how all of this works. Flip to the next slide. So this final section of the talk, I will give you a quick glimpse of where I think a lot of this excitement will go. I hope that some of this talk has help share some of the enthusiasm we as engineers feel for how much more there is to be done here. Make them electronic. That was still the same thought about turning from atoms to bits. Now, what if I can go one more step? What if I can walk around with my phone and recognize every piece of text in the visual environment? What if I can walk around with my phone and see that sign over there, or see that restaurant menu on the window, and recognize it, and speak it, and translate it? That leads to things that 5 years ago would have seemed like science fiction. But let's remember, a lot of the things that we can do today, 15 years ago, they too felt like science fiction, right? So if I can, so maps was about bringing all the world's maps online. Then we got Street View. Today you can sort of look at any part of the world. What happens as we get smarter? What happens when we expand the meaning of all the information in the world to all the objects in your visual space? You can start dreaming about cars that drive themselves. That too will happen, right? So similarly, think about this whole space of understanding what the user needs. The device can sense. The devices are becoming more and more aware of the user. Alan talked about getting that new phone, signing in, and getting all his applications. When I take a new phone and sign in, not only do I get all my applications, my phone suddenly knows that it needs to talk to me, so it starts talking. There's nothing special I need to do. That's enormously empowering, both from convenience point of view and a cost point of view, because 20 years ago, even 5 years ago, as a blind user, you'd have to buy special software for a special phone, and at the end of the day, it would cost you 3 times as much. Today, I can take a generic phone, sign in as myself, and everything becomes my phone. It talks to me, right? So devices become aware of your needs, and as you do that, the level of access we can deliver becomes wonderful. I'll flip to my final slide. So I'll conclude this talk where I began. So our work is about bringing better access to all the world's information to everyone in the world. And as we push the envelope on this, we work on both of those axes. One is all the information. What is all the information? The meaning of all the world's information has changed in the 5 years I've been at Google, and I expect that to continue. It continues to expand. The meaning of universal access, as in wherever you are, continues to change. The level of connectivity we have, we are just beginning to scratch the surface. And finally, being able to provide that access in the form you want. It's a truly exciting time. Let's flip to my next slide. So engineers can dream. That's my dog flying a 767. I'll leave that slide up and we'll do some demos. Again, these demos are just beginning to scratch the surface. We're going to show you these demos on Android. Charles has the phone connected to a projector there, and for this talk we actually set that phone up to be completely in Mandarin, which is why he's doing the demos, because if I did it I wouldn't understand what the phone was doing. So the first demo we are showing you is something we call the eyes-free shell. It's a shell that we developed. So the shell is sort of this home screen application on the phone that you use to launch all your favorite activities. Its goal is to give you one-touch, very quick access to the things you want. The first thing I'll have Charles show you is the eyes-free shell, and he'll show you very simple tasks like checking the time and check the battery level. It uses a touch interface that we created that I'll demonstrate in a little more detail after that when we do the talking dialogue. So Charles, go ahead and show time and battery on that.
10:27上午12月起，电池79%。
So notice that he is actually touching the screen and moving his finger. What we needed to develop about 2 years ago was to come up with an interface, as I said, that you could use without looking at the device with one hand while your eyes were busy. And I also believe very strongly that for a smartphone to be a good smartphone, it had to be a really good phone first, so you have to call people easily. So we developed this thing that we call the stroke dialer. And the idea there was, when you're not looking at the screen, you shouldn't have to go find the buttons. The device is smart enough that the buttons can come find your finger. So Charles will show this to you. What happens is that wherever you touch the screen becomes the center of the phone keypad. And once you know where the center is, you know where all the digits are. So Charles showed them 5.
逗号盘，电话，5。
So wherever he touches is 5. Now, when he touches down and moves up, you get up. So touch it down and go down. So notice that it's a very simple intuitive interface that we designed originally so that I could use it. It turns out that now Charles makes all his phone calls that way that he can see because it's just faster when you're not looking at the screen. And this works, so this kind of interaction, right, is sort of gives you insight into what kinds of things we can do, because now you can actually focus the rest of your attention on other interesting things. Charles, let's go to the Intersection Explorer. So I'm going to show you an application we built on top of Google Maps that lets me learn the layout of streets. We originally built this sitting on the Mountain View campus, and we got very excited when we went outside and we could actually move your finger and say, it would say, if you move 200 meters west, you will come to the street. What is truly amazing once you build this is that using that little phone, because all the needed information is on the cloud, it actually works anywhere in the world. Can you bring up basic thoughts?
应用程序 Intersection Explorer Intersection Explorer 新大陆108米的广场东侧路和新大陆
So the way this works is that you put your finger down and then you move it in a circle, and as you move it tells you where the streets are, and it vibrates as you move over a street. And then when you pick your finger up on a particular street, it moves along that street, tells you how far you moved, and tells you the next intersection. So you can sort of browse around with it. And the other half of this demo, I won't be able to show you inside the room because it needs GPS and we are walking around. But what happens when you're walking outside and you have a network is that we then give you walking directions to wherever you're going. So it speaks. So it says, in 10 meters turn left on this road. And not only that, because the phone knows where you are, it has a compass, it knows which direction you're going. It tells you the direction you're going in, and it also tells you what you're passing. So it's almost as if you were seeing where you were walking. It's a very, very fun thing to have. The final thing I'd like to show you is something called Places Directory. This is an application that lets you, wherever you are in the world, find out what's around you. So think about where we've come with respect to this, right? So you land in a new city, you pull your phone out, you can find out what's nearby you in terms of attractions, restaurants. You can get walking directions from it, and you can walk. Now, this is amazing for anybody, but when you sort of think about what I as a blind user had to do 20 years ago when I was a student, I actually needed a professional mobility trainer to come and walk with me on all the streets that I needed to learn before